Good day, everyone. I'm Caltris Alagaray, and I will discuss to you about the different sources of electricity. But first, let's simply define what is electricity. So, electricity is simply the flow of electrons from one place to another. Electrons are tiny particles that orbit the core of an atom, and they can be made to hop from one atom to the next. So, electrons move very easily through metal wire, but flow of electrons is limited by the size of the wire. So increasing the wire size allows for more electrons flow through it and for electricity to be delivered safely to homes and businesses. The word electricity comes from the same root word electron. So electricity is all around us, powering technologies like our gadgets, lights, soldering irons, and air conditioner. But what exactly is electricity? This is very complicated questions. There really is not a definitive answer, only abstract representative of how electricity interacts with our surroundings. So now, let's proceed to our main topic, which is the different sources of electricity. So, here are the different sources of electricity: the solar, the hydro, the wind, the tidal, the geothermal, and the biomass. So these are renewable sources of electricity that are sources of energy that produces naturally, such as sun, wind, and water. So the first um, source of electricity is the solar. So solar is the amount of sunlight that strikes the Earth's surface in an hour and a half is enough to handle energy consumption. So how does solar work? So solar radiation is light, also known as electromagnetic radiation, that is emitted by the sun. So I guess we're all familiar with this. So solar technologies capture this radiation and turn it into useful forms of energy. The solar technologies convert sunlight into electrical energy either through mirrors that concentrate solar radiation. This energy can be used to generate electricity or be stored in batteries or thermal storage. So, provided are the advantages of the solar um, panel. So, first one is solar power is pollution free. So, it causes no greenhouse gases to be emitted after installation. So, second is reduce dependence on foreign oil and fossil fuels. So, third, renewable clean power that is available every day of the year, even cloudy days, provide some power. Fourth, return on investment unlike paying for utility bills. Fifth, virtually no maintenance as solar power lasts for over 30 years. 6. Creates job by employing solar panel manufacturers, solar installers, and etc. So it turns helps the economy. So 7. Safer than traditional electric current. 8. It can be used to heat water, power homes, or even cars. So 9. An excess power can be sold back to the power company if the grind inner take tie. So the last one is no trenching is needed since the solar can be close to an out of the place installation. But with all of that advantages, it has disadvantages. So the disadvantage of the solar is that it is a high initial cost for material. However, with the reduction in the cost of solar over the last 10 years, solar is becoming more cost feasible every day. So the next source of electricity is the hydroelectric. So, hydroelectric is a power plant refers to a moving water that spins the generator to create electricity. So, hydroelectric, also called as hydropower, electricity produced from generators driven by turbines that convert the potential energy of falling or fast flowing water into mechanical energy. So, turbine is any of various dances that convert the energy in a stream of fluid into mechanical energy. So, the hydropower is one of the oldest sources of energy for producing mechanical and electrical energy, and up until 2019, it was the largest source of total annual U.S. renewable electricity generation. Thousands of years ago, people used hydropower to turn paddle wheels on rivers to grind grain. So it has three types of hydroelectric power. So the impoundment, the diversion, and pump storage. So impoundment is a facility with the most type of hydroelectric power plant. So a dam is used to store river water in reservoir at an impoundment plant, which is usually a big hydroelectric system. So water released from the reservoir spins a turbine, which then activates a generator, which generates power. So the water might release to satisfy changing electrical needs as well as other purposes, including flood control, recreation, fish passage, and other environmental and water quality concern. So, second type of hydroelectric power is the diversion. So, a diversion, sometimes called a runoff river facility, channels a portion of river through a canal and or a penstock to utilize the natural decline of the river bed elevation to produce energy. So a penstock is closed conduct that channels the flow of water to turbines with water flows regulated by gates, valves, and turbines. A diversion may not require the use of a dam. So the last type of hydroelectric power is a pump storage. So the other type of pump storage hydroelectric plant can store electricity generated by alternative energy sources such as a solar, wind, and nuclear power for later use. So these plants store energy by pumping water from a lower elevation reservoir to a higher elevation reservoir. So a pump storage facility stores energy by pumping water of lower reservoir to an upper reservoir when demand of electricity is low. So during times of strong demand for power, the water is released into the lower reservoir where it turns turbine which generates electricity. So here are sizes of hydroelectric power plants. So a large hydropower, small hydropower, and the micro hydropower. So a large hydropower, although definitions differ, the Department of Energy classifies major hydropower plants as those with a capacity of more than 30 megawatts. So a small a small hydropower, um, although same definitions differ, it is a project that generates between 100 kilowatts and 10 megawatts. So the last one is the micro hydropower. So a micro hydropower plant has a capacity of up to 180 kilowatts. So a small or micro hydroelectric power system can produce enough electricity for a single home, farm, or village. So the third source of energy is the wind. So, wind energy or wind power is a type of solar energy that explains the process of using wind to generate electricity. So, wind turbines transform the wind's kinetic energy into mechanical energy, and the mechanical energy can be converted into electricity using a generator. So, mechanical power can also be used for specific purposes such as water pumping. So, the fourth source of electricity is the tidal. So, tidal is one of the most ancient sources of energy. So, it is a renewable energy source that uses the natural rise and fall of the tides to generate electricity. So, exactly, tidal electricity can be generated using a variety of methods. So, some are the most common of which being is tidal barrage, tidal fences, and tidal turbines. So I don't know if I pronounce it correctly, but then yes, the first one is tidal barrage. So it is the most efficient tidal energy sources. So a tidal barrage is a dam that utilizes the potential energy generated by the change in height between a high and low tides. So this energy turns a turbine or compresses air which generates electricity. So next is the tidal fences. So tidal fences are turbines that operate like giant turnstiles, while tidal turbines or the last is similar to the wind turbines only underwater. So in both cases, electricity is generated to the mechanical energy of tidal currents turns turbines connected to a generator. So ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. So that's it. It's about the tidal, a source of electricity. So the fifth one is the geothermal power or geothermal. So geothermal power use steams to produce electricity. So this steam comes from resources of hot water found a few miles or more below the Earth's surface. So the steam rotates a turbine that activates a generator which produces electricity. So there are three types also of geothermal power plants. So these are the dry steam, flash steam, and binary cycle. So a dry steam power plants um, drawn from underground resources of steam. So the steam is piped directly from underground wheels to the power plant where it is directed into a turbine or generator unit. So compared to the flash steam power plants are the most common and it is used geothermal reservoir of water with temperature greater than 360 degree Fahrenheit or 182 degree Celsius. So the last type of geothermal power, which is the binary cycle or the binary steam, plants operate on water at a lower temperature of about 200 to 225 to 360 degree Fahrenheit. So binary cycle plants use the heat from hot water to boil a working fluid, usually an organic compound with low boiling point. So that's it. That's about the geothermal source of energy. So the last one is the biomass. So biomass can be converted into electric power through several methods. So the most common is direct combustion of biomass materials such as agricultural waste or moody materials. So other options include gasification, pyrolysis, and in anaerobic digestion. So gasification um, produces a synthesis gas with usable energy content by heating the biomass with less oxygen than needed for complete combustion. So the pyrolysis yields biooil by rapidly heating the biomass in the absence of oxygen. And the last one is anaerobic digestion. So I guess it is common to us where I see it also in TikTok videos. So anaerobic digestion produces a renewable natural gas when organic matter is decomposed by bacteria in the absence of oxygen. So it is um, about the biomass as source of electricity. So by that, the different methods work but with different types of biomass. So typically, woody biomass such as wood chips, pillars, and sawdust are combusted or gasified to generate electricity. So the corn stover and wet straw reduces are built for combustion or converted into a mid energy content gas in an anaerobic digester. So in addition, most other types of biomass can be converted into bio oil through pyrolysis, which can then be used in boilers and furnaces. So all biomass systems in general require fuel storage space as well as fuel handling equipment and controls. So a bunker or they for short-term storage and an outdoor fuel yard for longer-term storage is usual in a system using wood chips, sawdust, or pillars. So that's all about my report of the different types of sources of electricity. So I hope you learned something from my discussion. Thank you and God bless. So here are, in case if you didn't really understand about my discussion, so here are some of my references that might help you